All right, good afternoon, everybody. I'm Fox 2 News meteorologist Chris Higgins with the upcoming winter weather event moving towards St. Louis. Time for a corner update. This is a video update for Wednesday, January 27th. Tough winter forecasting definitely lies ahead. The details of this forecast will certainly be altered or massaged over the next 36 hours, 48 hours as we lead into the event. I'll explain a little bit about that and why, and just give you a quick recapitulation of what I'm thinking here in terms of a forecast. The storm system we're tracking for Thursday night into Friday is still way out here to the west. It's still actually quite a bit of it off the coast of California and off Mexico. Really, the morning model run's only sampling about a third to a half of the overall circulation. So until it's entirely onshore, there's going to be some suspicion as to the accuracy of the model data about the eventual forecast here. But that is something we'll have to wait for. Hopefully it will be further onshore and we'll get even better forecast data coming in from the Zero-Z model runs this evening. But right now it's still got a ways to go. The front half or so is onshore. The other problem is once it moves in, it's going to track across, at least for a while, a data sparse region of northern Mexico. So it may be a while before we get a really good read on the storm system, perhaps not even until it emerges out into West Texas, less than 24 hours before it hits the bi-state area. All right, believe it or not, I'm actually going to end up using the GFS this time around. It's pretty close, reasonably close to the Canadian, and looks far more reliable right now than the updated NAM model. As we've mentioned in some of the written discussions on my blog earlier this morning, the NAM, the latest update of the NAM, just looks way out into Never Never Land in the way it's operating with the system for some reason with this model run. So we're going to stay with the GFS Canadian combo, and for simplicity, staying with the GFS. This is the 36-hour forecast, so this would be Thursday evening. 500 millibar closed circulation, very well formed over northeastern Mexico, and just from a conceptual basis, that is a good location for a closed low to be if we're looking for snow to build into portions of Missouri. So that looks good in that general location. At 42 hours, that closed low eases slowly off to the east into the Texas Panhandle. Still a lot of vorticity and short waves wrapping around that upper level low. One of the characteristics that the models have is they sometimes weaken these things too quickly as they punch into a confluent flow. Overall, the upper low should be shearing out a little bit as it moves to the east. That's to be expected, but with such a well-formed and tightly packed circulation, I think it may take a little bit longer for this thing to fall apart. But nonetheless, the overall presentation here at 500 millibars at 42 hours or at midnight Thursday night going into Friday morning still looks pretty good. And conceptually, you would expect snow or precipitation to be breaking out up to the middle of the confluent zone, so just south of St. Louis, just south of Kansas City to just south of St. Louis as we go through late Thursday night into very early Friday morning. Here we are now at 48 hours, and you can see the upper level low has opened up at 500 millibars in a shortwave, rapidly releasing and shearing out of that low to the east. You'd expect pretty good vertical motion right ahead of that vortmax across central or southern Missouri, perhaps up into northern and central, or at least the central portions of the state up to the I-70 corridor and points onto the south. Again, this may be a little fast on the breaking of the upper level low, but in general the trend here does make sense. Going back to where we started here, this is going to be the Thursday evening, tomorrow evening surface chart. Surface high pressure at 1036 diving into southwestern sections of Iowa, and you can see the moisture streaming northward. This is precipitation ahead of an inverted trough. There really is no true surface system yet developed with the storm. It's mainly an inverted trough with intense precipitation and vertical motion out in advance of the 500 millibar system. In general, the models are just a little bit further north and west at this time frame from where they were earlier. Push you forward in time now. This is going to be at midnight, Thursday night into Friday morning. Surface high pressure weakening somewhat as it gives way to the north, allowing moisture to surge northward. The leading edge of the significant precipitation, and it looks like there'll be two fields here. This pocket is associated with the vortmax that you see over Kansas and portions of Oklahoma. That's ahead of the upper level low. This band here is primarily warm, arid, vection driven as it's the low-level flow is pumped up with moisture and up over the top of the surface cold dome. Taking you to Friday morning, that warm air advection zone, as it runs into the confluent flow and the high pressure, gets squashed a little bit and begins to bleed off to the right or to the east as it works its way into the confluence. That really is a key part of this forecast, is just how strong will that confluent flow remain and how much moisture will be able to be drawn further to the north. You can see back here, associated with the upper level system and the advancing shortwave that's ejecting out of the upper low, there's still a pretty good area of QPF, of precipitation back here in the snowfield in Kansas that should translate to the east along with the shortwave and upper level low, or what's left of it, as it kicks eastward during the morning hours on Friday. Which brings us to the 18Z, or midday map, for Friday. And the GFS doing a pretty good job here overall with this run, bringing the warm air advection and low-level frontal genetically forced precipitation, very intense precipitation at that, in that band along the inverted trough from Louisiana up into western Tennessee. That's where it intersects the confluent flow, and again continues to pan off and veer off to the right to the east. Meanwhile, you can see this lagging area of precipitation back to the west. That is still in association with the remnants of the upper level system as it streaks on to the east. While that's all happening, we have to look upstairs at 300 millibars, because that's where we have the jet coupling that we've been talking about. The NAM completely lost it. The GFS now has it, although not quite as long as before, but it still has some interesting features here. This is the morning hours, around 6 a.m. on Friday morning. You have the strong upper level jet stream here over the Great Lakes. The right rear quadrant would focus intense vertical motion right on the I-70 corridor right in here. At the same time, you have an ejecting jet streak coming out of the southwest around that upper level low, merging with the jet streak to the north. So that would provide favorable lift generally in the area from southeast Kansas into central Missouri. So where these two overlap, basically along the I-70 corridor in south and southwest, would theoretically, conceptually be an area of enhanced vertical motion. Moving it out to 54 hours, or the midday hours on Thursday, notice how we kind of start to get this fish hook again, where the upper level jet streams merge and it begins to back build somewhat to the west and southwest. That has a tendency to increase the vertical motion and help draw the precipitation shield further north than might normally be expected. Fish and I were talking about this before. It has happened in the past. We've seen it happen. It would tend to occur in an area right now with this feature somewhere from southern Missouri into southern Illinois. Coincidentally, at the same time, there's still a fair amount of, in fact, a very strong signal in the 700 millibar layer of 700 millibar frontogenesis with the compressing of the thermal gradient and a healthy amount of moisture here. We're still dealing with upward motion, and I still think that the models are probably underestimating somewhat the potential for additional snow behind the system underneath this plume of moisture that lags across central and southern Missouri into southern Illinois. And through 0Z in the evening on Friday evening, so Friday evening into Z time Saturday, you can still see that tongue of moisture lagging back in the frontogenetically forced zone here across southeastern Missouri and southern Illinois. Models indicating some very light precipitation with this. Would not surprise me at all to get somewhat more impressive snowfall in this area as well, still lingering over southern Missouri and southern Illinois. So where does that leave us with snowfall potential? Let's take a look. This is my forecast of record as of Wednesday afternoon. I think the heaviest band will align closest to the low-level thermal gradient and just on the cold side of that. So from, let's say, north of Joplin through the Springfield Lake of the Ozarks area, and then in our viewing area, long and south of a line from Salem over towards Fredericktown and Ironton, and then south towards Cape Girardeau, Poplar Bluff, and Lesterville. Solid 7 to 12 inch snowfall there extending across the river into southern Illinois east of Cape Girardeau. Further north, still impressive snows here, but slightly less, 4 to 7 inches, because you'll be further displaced from the low-level thermal gradient. And a lot of this will be tied to that upper-level jet coupling. But from Rolla to Potosi to Chester and south side of Mount Vernon, I think a solid 4 to 7 inch snowfall is a pretty good bet. And that could extend as far north as let's say Cuba and Bourbon, and then rich woods, and then maybe even southern sections of Jefferson County across the river to near Evansville in Illinois. South of that area, you can see where that band is 4 to 7 inches. And then finally, the most difficult part of the forecast, as far as I'm concerned, happens to be right through the heart of the metropolitan area along and south of Interstate 70. I know it seems like a broad brush, but it truly is going to be a rapid drop-off from a dusting on the north side to a quick 4 inches on the south side. A lot depends on the evolution of that band with the upper level system and the jet coupling, but I really think that's the best way to capture the overall trend of a very sharp drop-off. Ultimately, this may be just a touch too far to the north, but I think this is the best way to go in case the models do trend a little bit further to the north, as is entirely possible based on the jet structure.